If the molecular formula gives the actual number of atoms in a molecule, empirical formula gives the smallest whole number ratio of atoms in a compound. So how do we solve for the empirical formula for compound? So we always assume to work on 100 grams of compound, and that the percentage is the same as of grams. And then we have to convert whatever percentage or grams is given into moles. So let's have an example. A compound is found to contain 18.5 carbon or 18.5% carbon and 81.5% oxygen. Solve for the empirical formula. So again, we are going to assume that of a 100 gram sample. So our 18.5 can be written as 18.5. Instead of percent, we're going to write it in grams. Carbon multiplied by 1 mole carbon over by the molecular weight, or 12.011 grams carbon. So we have to cancel this, and this will give us 1.54 mole carbon, right? Okay, let's add an E here. Okay, now let's do the second one. We have 81.5%, rather instead of percent, and the second one is 81.5 grams oxygen multiplied by 1 mole oxygen over by the molar mass, which is 15.999, is equals to 5.09 mole of oxygen. Now, the next step that we're going to do is divide these two equations, okay, by whichever has the smaller value between the two. So for in this case, you have to divide it by 154 or 1.54. So it's 1.54, 1.54, and this will give us 1. This will give us 3.30, and we do not want a decimal point or decimal place in the empirical formula because it should be expressed in whole number. So we have to use our cheat sheet. So this is our cheat sheet. Okay, now let me explain you how this works. If the decimal place ends in 1 to 5, so you have to multiply by 8. If it's 0.25, you have to multiply by 4. If it's 0.3 or 33, you have to multiply it by 3, so on and so forth. So in our case, we have 0.3, so we are going to use this one. So let's multiply it by 3. Then we have 3, and then this becomes 9.9, or just simply 10, right? We round it off. So the empirical formula for this compound is C3O10. Alright, let's have another example. So a compound is found to contain 25.9% nitrogen and 74.1% oxygen. Calculate the empirical formula. So again, we have to assume that these are 100 gram sample. So we have 25.9 grams of nitrogen multiplied by 1 mole of nitrogen divided by the molar mass, which is 14.0. So I am using the rounding off grams, or the rounded number here at the bottom, so which is 1.85 moles of nitrogen, right? And then the second one is the oxygen, which is 74.1 grams oxygen multiplied by 1 mole oxygen divided by its molar mass. So since I use the rounded off molar mass, I'm going to use a rounded off here also, or rounded number. Okay, grams of oxygen is equals to 4.63, okay, moles of oxygen, right? So we're not yet done. The next step is to multiply it by whichever number is smaller between the two. So it's 1.85. So let's divide it by 1.85. Okay, that gives us 1. Then here is 2.5. Now, we have another scenario here, which is 0.5. Okay, so we want to remove the 0.5. So we have to think of a number or use our cheat sheet here, okay, to come up with the whole number. So since the ending is 0.5, so we have to use this one. Okay, let me change the color of my ink. So we have to use this one. Okay, so we have to multiply it by 2, right? So let's multiply it, okay, by 2. Multiply this by 2. This gives us 2 and then 5. Okay, so 2 nitrogen and then 5 oxygen. So this gives us N2O5. So this is the empirical formula for the compound. Okay, again, we only use the number here, okay, also here, because we want to remove the decimal point, okay, or the excess, which is the 0.5. Okay, that's why we decided to choose to multiply it by 2. Okay, let's have one more. Compound contains 43.64% phosphorus and 56.36% oxygen. Calculate its empirical formula. So let's write it down. It's 43.64 grams of phosphorus multiplied by 1 mole of phosphorus divided by the molar mass. Okay, we will use again the rounded number for the molecular mass of phosphorus, which is 31. This will give us 1.41 mole of phosphorus, right? Then the second one, which is oxygen, so we have 56.86 grams of oxygen multiplied by 1 mole oxygen, and then the molar mass is that is 16 rounded off. This will give us 3.5 moles of oxygen. So the next step, after converting grams into mole, okay, we have to divide it by whichever the smaller number is. So in this case, we have 1.41, right? So let me write it down. So it's 1.41 divided by 1.41. That gives us 1. That's for phosphorus. Okay, for oxygen, it's 3.5 divided by 1.41. That gives us 2.5 oxygen. So again, there is an excess at decimal point, which is 0.5. So based from our cheat sheet, if that is a 0.5, you have to multiply it by 2, okay, to remove the decimal point. So multiply this by 2, multiply this by 2. So we now have 2 phosphorus and then 5 oxygen. So if we're going to write this, it will be P2O5. So this is the empirical formula for the compound.